Alrighty, we should be good to go. So, picking up where we left off, if you guys haven't seen part 1 of this lesson yet, I suggest you do that first, because otherwise this is going to look like quite a mess, especially with this integral and an exponent up here. But hopefully you guys have seen part 1. We will continue from there right now. So, just a brief recap. This is mu of x. This is one function that we're going to use. We're going to use this and chuck this into a separate, bigger function that will give us the function y that satisfies any dE of this format. Alright, so I'll say that one more time. We're going to use this up here, throw it into some other formula that equals y. And when you plug in all the things you need for mu and a couple of other things that we're going to see in a moment, and you get a final answer out the other side, it's going to be a function of x that satisfies the dE that you started with. So y prime, whatever it is, plus whatever this function is, times y, equals whatever function that is. Whatever those things are, you can get the final answer using the formula for any first order linear differential equation. So, the mu bit we've covered, and here's where the mu bit comes in. Alright? So, I'm going to erase this now. Hopefully you guys have it copied down. So, just make note of the fact that we have used the q information that we were given up there. We didn't know y prime because that would just give us y if we did an antiderivative. And we don't know y, that's what we're trying to look for, but the piece of information we haven't used yet is g. And so that's actually going to come in next in a bit of a weird formula. So the formula that will give you y, the guess for the function y, for any first order linear differential equation is y equals 1 over mu of x. Alright, so it's 1 divided by that whole thing, whatever it evaluates to, times the integral of mu of x times g of x dx. And I'm going to put this in. Technically, you don't need to write this down when you write down an integral. I'm putting this in so that you don't forget when you're solving a question. Plus c needs to go at the end. And I've found it to be quite useful to actually write in that plus c separately, and then when you do the integral you just tack on the plus c at the end, and that'll give you your final answer. So this is the formula that you'll use for y. And so what does this mean? This mu thing you can figure out based on this. It's e, which is a number. It's going to be e to some exponent, because e loves to, it's an exponential function, it loves to work with exponents, right? So this exponent is what you need to figure out. And so this q of x bit up here, usually it'll be something like 2x or something. Maybe it'll be 2. Okay? So for example, let's say q of x was 2. Then the integral of 2, the antiderivative of 2, is 2x, right? The derivative of a constant is the constant times x, right? So it's e to the 2x if q of little q of x was 2. Alright, so then we could solve for our mu bit up here. We haven't done an example yet, so that might be a little bit confusing that I just kind of threw a piece of it at you, but I'm just trying to explain how it works. So you'd have a value for this q of x thing, and this should, in most cases, in every case I'll make sure to pull examples right out of my notes. It'll be really easy to solve the integral up in the corner. The value for a q will be something fairly straightforward, something that's either an integral that we've already learned, or I'll give you the answer that this is a special type of integral that you should now know for the rest of May. Alright, so that bit is easy to solve, and if you can solve for that with whatever information you've been given about q. That means that you can also solve for this bit right here and this bit right here, right? G of x you'll also be given. This whole integral could be a little bit messy to solve because you've got this piece that you already figured out from up top, and you've got this piece that was given to you by the question, so it's not necessarily going to be easy. It could make sense to multiply them together if it's like 2x and 4x or something. Then you could just multiply it together and then do the antiderivative of that. But sometimes it'll be advantageous to leave them in pieces and do integration by parts, because if you do it by parts, it's already broken up into two chunks for you, right? It could be your u and your dv, for instance, right? It's not always going to be that way, but it could be that way. So if it looks complicated for when you multiply it together and you're getting some really weird numbers or some weird symbols, like if there's like trig functions and stuff, maybe don't multiply it together and try to do integration by parts. I'll try not to give that stuff to you guys, but don't worry about that just yet. I don't actually know if we'll get to a practice question today because I've only got another 10 minutes-ish. So this is the formula that'll give you y. So you'll already have figured out mu from up top, which means you figured it out here as well. You've been given g, so if you can figure out this integral, you just multiply it by 1 over mu that we've already figured out, and it'll spit out something for y. Incredibly, if your dE is something that's like y equals y prime, then, actually maybe we'll do that as an example, it should, ideally, give you just e to the x in that case, right? That's an example that we talked about, and it's a simple case of an example. So that is the formula that you need. Just making sure I haven't left anything out of my notes exactly. Alright, we're good. So we'll go over that as an example. I'm going to leave these formulas up here. So our function is just, our question is y equals y prime, right? And so what this means is, we already know because we talked about this before, that this is going to be e to the x, because the derivative of e to the x is just e to the x, right? So we know what our answer is going to be. But to write it in the form that we need, we're going to have to get it into the y prime plus something times y equals something else, right? So if we bring this y prime over, it's going to become negative, right? So it's going to be negative y prime. Think of it as subtracting y prime from both sides. So you have negative y prime plus y equals, and you subtracted a y prime from the right side before. So you have nothing over there right now, right? You got a 0, okay? Now, we don't want the y prime to be negative. Remember, if you look back at your equation in your notes, it's supposed to be y prime by itself, positive y prime, plus something times y. And so what we can do is if we multiply this whole thing by -1, then we get rid of this minus sign right here. The 0, it doesn't matter. And this plus sign in the middle just changes to a minus sign. So you multiply every term by -1, and the negative y prime becomes positive y prime, the positive y becomes negative y, and 0, it doesn't matter if it's positive or negative. There's no such thing as a difference between positive 0 and negative 0. It's just 0, right? So now we've got this in a form that we can work with. This is in the form y prime plus little q of x times y is equal to little g of x. Right there. Alright? So y prime we know. Q of x, if you look at this and the one above it, it's supposed to be plus qx, or a q of x, right? It's supposed to be plus q of x. And up here we've got minus y. So what that tells us, if you look at it if you just stare at it for a second, what that tells you is that q of x has to be -1. Alright? Y prime plus -1 times y. -1 times y is just negative y. Y prime plus negative y is just the same thing as y prime minus y, right? Y prime plus negative y is the same thing as just y prime minus y. Alright? So that means that we know q of x right here is just negative 1. Alright? So I'm going to write that down over here on the side. We know little q of x is equal to negative 1. So notice that it doesn't always have to be a function of x, because in this case x doesn't show up. All that matters is that you don't have like y showing up or some other variable, alright? So it could have no x's or it could have some x's, as long as it doesn't have anything besides numbers and x's, alright? So q of x is negative 1. And if you look on the right hand side of the equation, we know little g of x is just 0 from the previous line, where we'd rearrange to get y prime minus y equals 0. Alright, so we know what q of x is, we know what g of x is, and now we can move on into using that formula up top, right up here. Alright, so using this, e to the integral of q of x dx. Well, we know little q of x is negative 1, right? So I'm just going to stick in a negative 1 right there. Alright? And if you do that integral, what you should get is you can just pull out the negative sign right out here, and so then you just have the integral of dx, which is just x. And so what you have here is e to the negative, because you pulled it out of the integral, and then the integral of dx. So what I did is I went from the integral of negative 1 dx, I changed that to pulling the negative sign out here, and then the integral of 1 dx, that's just the integral of dx, which is x. Alright? And the negative sign stays out front. So e to the negative x. And so that's the whole thing. That's the whole thing for mu. Alright? So mu of x, we now know, is just e to the negative x. And so what we can do is we can actually plug that in right over here. E to the negative x. And we can also plug it in right over here for mu of x over here. E to the negative x. Now, this actually gets nice and easy, because the next thing we have to plug in is g of x. But little g of x here is 0. And so if you plug in a 0 for this, all of this is being multiplied together. Taking the integral of 0, you're just left with a constant, right? If you take the integral, the antiderivative of 0 is just a constant, because the derivative of a constant is 0. Alright? So you plug in the 0 for g of x right here. And then this whole integral, all the way up to the end of the dx right there, is just gone. It's just because, and the reason it's gone is because the answer to the whole integral is c, the constant. But we already wrote out the constant at the end, meaning this whole integral in the middle just disappears. And what you're left with is the little c at the end. Alright? That's all you're left with. And I'm going to just move that c over and shrink the brackets down. So you've got 1 over e to the negative x times c. Alright? Because these are just multiplied, I could actually even just get rid of these brackets and throw the c up top here, just by multiplication of fractions, numerator times numerator. The 1 was the numerator here, and the c was the numerator in the brackets, which is technically c over 1. And I'm almost out of time. So if you look here, e to the negative x, if you look at your exponent laws, you could change the exponent to become a positive exponent as long as you flip the fraction. So you've got e to the negative x in the denominator, and what you can do is you can make that e to the positive x in the numerator. And so you keep the c in the numerator, and then you just make it e to the positive x. And try it out yourself. If you put in y it being e to the x, or like e to the x with some numbers sticking out in front, it should work out for you. For us, for what we tried, we kept c as just 1, and then your answer was just e to the x. I'm almost out of time here, so I hope that makes sense. I'm sorry I rushed a little bit in that last minute. If you guys have any questions, let me know. Otherwise, I will see you on Monday? Yes, Monday. All right, have a good weekend.